trying to graph, and you maybe had one that looked like this, y equals 2x plus 4, and then you had like x equals 4x plus 8, and you had to graph that. And how easy is it to graph it when it's in the x term? X equals whatever. Bob, how easy is that? Oh, there is 2 x's. That's a y. Good call. I owe you, well, here, I'll show you one of these. I need to dig and find my Smarties. You go to the 0? Your arm caught it. That was a beautiful armpit catch there, Bob. So can we graph this? Can we put that in slope-intercept form? Yes, we can. Is it easy? No, it's not. I mean, it's not the hardest thing that ever happened, but it's also a giant pain in the butt, right? So how would I get this y alone? What's the first step to get that y alone? Okay, Cheyenne.
You minus the 8.
We're going to subtract this 8 from both sides, right? So we have x minus 8 equals 4y. And now what do I do to get this in slope-intercept form? What am I going to do, Ellie?
Divide by 4.
Divide all the things by 4. And I end up with 1/4 x minus 2 equals y. Where's my y-intercept? -2. My slope is 1/4. Was that the hardest thing in the world to do?
No.
No, but it wasn't the easiest thing in the world to do either.
No.
Actually, no. And honestly, if life gives me x equals 4y plus 8, I'm not graphing that. There's a better way to do these, and it's called substitution. Okay, I'm going to show you how this works. So I'll be real with you. When I have encountered systems of equations in my life in the life of science, you know, I don't generally, like, I'm at Walmart, right? And I find a system of equations and I need to suddenly solve them. That doesn't happen. But it does happen in science that you'll have a system of equations, like it really does. So if I have a system of equations, probably about 1/3 of the time I solve them with the addition method that we had last Wednesday. I'll solve them that method. 2/3 of the time, I solve them this way because it's just easiest most of the time. There are some steps, but we'll work you through the steps. Okay, so let's look at example 1. We have 4x minus 3y equals 12. And then we have y equals 5x minus 15. Now, could I graph these?
No.
Technically, yeah, I could totally put this in slope-intercept form. Slope-intercept form is y equals 3/4 x minus 4. Totally graphable. These are totally going to intersect. But do I want to graph it all the time?
No.
Do I have graph paper in my back pocket?
No.
Emmett, do you have graph paper in your back pocket? Show me.
Coulter Hales, please come check out. Coulter Hales.
No, put that there. Because Emmett last week said, oh yeah, I totally walk around with graph paper in my back pocket. It was last week. He doesn't. He lies. So nobody walks around with graph paper in their back pocket. Nobody wants to be graphing this crap. Nobody does. So there's an easier way. Now, can I solve these by adding them together easily?
Yes.
I mean, easily.
No.
I can't solve them by adding. I would need to get this 5x over there, and then I need to multiply this whole equation by 3 so that it cancel out with that -3, and then add them together and then solve for. So it's possible, a little bit cumbersome. I'm going to show you a different way today, and it's called substitution. And anytime I have like a y equals, I pretty much automatically use substitution. Okay? What does y equal in this equation? 5x minus 15. We don't have a solid number that y equals. Could be 7, could be 23. I don't know, but I know that it's 5x minus 15. So I'm going to take this equation, and everywhere I see a y, instead of y, I'm going to put in 5x minus 15. The y is going to disappear. I've noticed some of you when you're substituting, you're leaving that y there. The y completely disappears, and it's completely replaced by that. So let me show you how this is done. So 4x, does that have any y's in it?
No.
So we don't even worry about it. We have 4x minus, now this is 3 times y. So I'm going to have 3 times, it's actually negative 3 times y, but y is 5x plus minus 15. So I'm going to substitute in 5x minus 15. And what does all of that equal? 12. What do I have here? I have a linear equation in one variable. Can I solve that?
Yes.
This one has some steps to it. Have I taken you guys through the steps that we need to do to solve this?
Yes.
It's been a little minute, but we can do this. We've done harder than this. So let's do this. What step am I going to do first here? I need to do something. Trisha, wow, you are very excited.
We need to get the x's together somehow.
We need to get the x's together somehow. There's something we might need to do before that. Bob, what we might want to do before that? There's these parentheses here. I don't want them in my life. So we have a 3 times everything in the parentheses. How do I make those parentheses go away, Ellie? Divide? But I don't want to be dividing by 5x minus 15. I definitely don't want to be dividing by 3 because then I have to divide the 4 by 3. It gets ugly. So Jaden, how am I going to deal with this?
First, well, you're going to times everything by -3 since everything in the parentheses is...
Not everything, but just the parentheses, right? We don't want to times -3 by 4x. We don't want to times -3 by 12. Let's distribute that -3 to everybody in that parentheses. So this 4x, what happens to that on this step? It sits there. Maybe it grabs a box of popcorn and enjoys the show. Okay, so I have, remember, we're going to look at the sign in front of the 3. I have a -3 times a 5x. So what's -3 times positive 5x? What is it, KN? Negative 15x. And then I have a -3 times a negative 15. What's that one going to be?
45.
Eli, what's that one going to be?
45.
What flavor?
Negative.
Negative 45 or positive 45? Okay, well, how do I know if it's negative or
There's
positive?
a negative in front of the.
There's negative 15 times negative 3. If I have a negative times a negative, I have those 2 lines there right next to each other. It becomes positive. So positive 45.
Kale Spalletta, please come to the office. Kale Spalletta.
And that just equals 12. Nothing happens to the 12. We did not multiply the 12 by the 3, and we're there. So now, who told me that I wanted to get the x's together? That was Trisha. Trisha, I think now is a good time for that. Okay, so let's get these x's together. We have a 4x and we have a negative 15x. What's 4x, Jaden? What's that going to be? Oh, she's going to math that real quick for us.
19.
But this is a negative 15. So Cheyenne, what's it going to be?
Negative 11x.
Negative 11x. We got to watch our signs. We're going to do 4 minus 15, not 4 plus 15. Is anything happening with its 45? Does it have any friends over here we can combine it with?
No.
No friends for the 45. And we're back to a double step linear equation. Can we solve these?
Yes. Yes.
Like, hopefully in our sleep at this point. What are we going to want to do first? Let me grab, I have all the popsicle stick hands but one. Oh, that's the one I need. Okay, Ann, what's my first step in this equation here? I'm going to subtract 45 from both sides. I have positive 12 minus 45. So what is that going to give us? Who can math that for me? Plus 12 minus 45. Cheyenne, what is it?
Negative 33.
Negative 33. An easy way to do that. Their signs are different. The 45 is bigger, so I know it's going to be negative. And then I just do 45 minus 12. 5 minus 2 is 3. 4 minus 1 is 3. But I give the sign to the negative 45 because it was bigger. Okay. Negative 11x equals negative 33. How do I finish this guy? Trisha, what am I going to do?
You're going to divide 11x by 33.
By 33? Or do we divide? Bob, what are we going to do?
Divide everything by -11.
Divide by negative 11. Remember, we're going to want to divide by the thing that's next to the x. What is negative 33 divided by negative 11? What is it, Jaden?
Positive 3.
Positive 3. We have a negative, which becomes positive. The positives and negatives are going to kick your butts today if you're not careful, okay? So you got to watch them super close. X equals 3, am I done?
No, you need to circle it.
I need to do a little more than circle it. What else do I need to do, Cheyenne?
You need to figure out why.
I need to figure out what y is. How am I going to do that?
You pick a random problem.
Not a random problem, just one of these two. Does it matter which one I choose?
No.
Kind of it does.
That bottom one looks more complicated.
The bottom one looks a heck of a lot easier than the top one. If you choose the one that's the y equals, it's going to be less work. Because let me show you. We have 4x, so x is 3. So 4x, so we have 4 times 3 minus 3y equals 12. Double-step linear equation. Can we do double-step linear equations? Sure we can. But look at this. Or we could have y equals 5 times 3 minus 15. What's this?
0.
It's just an algebra problem, and it's not algebra, it's arithmetic, and it's 0. So, are they both going to give the same answer?
Yeah.
Actually, they are. But one of them is going to be easier. So choose the easier one, okay? So, x is 3, y is 0. So, my solution is 3, 0. And I circle it because once you're doing these, there's a lot of math there. And poor Mrs. Barlow has trouble finding the answer sometimes. So, please circle them. Should we do another one? Let's do another one. Let's do another one. Let's do the next one. Now, the next one's kind of nice.
Yeah.
So we have x plus 4y equals 11. And we're given the x. This one we were given what y equals. This one we're given that x equals what? 5y minus 16. Do you guys see why this one is a little bit nicer than the last one?
Yeah.
Why is it nicer? Why? What do you see, Trisha?
The X's are on one side, the Y's are on their side, yeah.
Well, I mean, that's the same as it was on the other one. We had the X's on one side and the Y's on the other. What's nice about this one, Bob? What do you see?
Less negatives.
Fewer negatives, and there's no term in front of the X. It's not multiplied by anything. Jaden.
All of them are perfectly lined up. The X's over the X.
Okay, can we add these like we did last time?
Yeah.
No, because that's an equal sign, not a plus sign, and that's a minus sign, not an equal sign. The numbers lined up beautifully, but the equal signs need to line up too, and they
Like a
don't.
pancake.
Doesn't? We're not gonna. We're gonna solve it by substitution today.
Yeah.
Cheyenne.
The x equals 5y minus 16.
Yeah, so x equals 5y minus 16. So I'm going to take this equation and I'm going to rewrite it. But everywhere I see an x, instead of writing x, I'm going to write 5y minus 16. So we have an x. Nothing's multiplied by that, though. That's why it's nice. 5y minus 16. And then I have plus 4y. 11. What's my first step on this, guys? What's my first step, Jaden?
You want to combine the negative 16 to the 11.
Not yet. Let's combine everything on this side of the equation. Because we have a 5y and a 4y that we need to get together. So, Clara, what's that going to be?
You subtract the 4y.
No, we don't want to subtract it. We want to combine them together. We have a 5y and we have a 4y on the same side of the equals.
sorry.
We don't
You
want to
add-
subtract those away from each other. We want them together. We want the y's together.
Sorry, I was mistaken. You add them together.
You add them together. So, what's 5y plus 4y?
9y.
9y. So we have 9y minus 16 equals 11. And now, Jaden, what do we want to do with this
You
16?
want to combine it to the 11.
We want to combine it to 11. How are we going to get that over there?
Plus 16 on both sides.
Plus 16 on both sides. So we have a 9y. What's 11 plus 16?
27.
What?
27.
27. How do I get rid of this 9?
Divided by 9.
Divide that 9 away, and we get y equals 3. Now, x equaled 3 and y equaled 3. I won't tell you right now, it's not always going to equal 3. It just kind of worked out that way on these two problems,
Yeah,
okay?
why did they equal 3?
Because they do. Like it just happened. Like it's a number. So we've got an infinitely many numbers to choose from, and it happened to be 3 on both times. But don't expect one of them to be 3 every time. So can I figure out what x equals now?
Yes.
Because x equals 5 times y, but y is what? 5 times 3 minus 16. Well, what's 5 times 3?
15.
So x equals 15 minus 16, which is what? Negative 1. And we have the solution, negative 1, comma 3. So they're pretty straightforward like that. No huge surprises. You have to do 4 of them on your own. That's the smallest number I could get so that you still get a decent amount of practice. So, not a bad method. Probably my favorite method, honestly.